All right then, so I can't be with you today. I do want to retest you on this this week on the Thursday. So I've made this video to go through this. I would recommend you take this home and maybe watch this video a few times. I'm going to go through where marks were lost. As always, we've got our formula sheet there, so I'll be referring back to this. But the first one is a Souvat question. So we've got a deceleration of minus 6.7, and as always, I'm writing everything I know. Time taken to stop. So when the vehicle stopped, it's going to be at the final velocity is going to be 0. And then its initial velocity is 13.4. That's his sort of starting velocity. At the moment, it starts to decelerate. We know that deceleration is minus 6.7 there. We don't know our time, and we've got no S, but it's asking for the time. So when there's no S, we look for the formula with no S, or with no X. So we're using Souvat, so the S is going to replace the X, which is displacement. But if we're looking for no X, or no S in this case, we're going to be using this formula. So V equals U plus AT. So that's the one I've used. And then I've filled in the letters with the numbers. And then once I start rearranging, because I've got 13.4 plus minus 6.7t, I've divided both sides there. I've plussed both sides by 6.7t. So I've given that each side, and then that 0 becomes 6.7t there, because I've plussed each side. So that equals that, and then to get t on its own, I simply divide both sides by 6.7, and that's going to give me 2. Okay, so if you're not strong on rearranging, I advise you to go and have a look at a couple of videos, or come and see me. I can give you some problems to have a go at. If this is where you're getting stuck on these, is the rearranging, then maybe you just need to pop in and ask me for some help, or any of the maths teachers will know how to do this. And then part B then is now it's asking for the distance, and I'd always recommend not using now, if you can, not using what you've just found out. So I'm going to say that there's no t, even though we just solved for t. I'm going to say that there's no t this time, but we're looking for the x or the s, Souvat, the xvat. It's the same figures, okay, but now we're looking for the displacement. So if I've got no t, I'm looking for, well, that's got a t, I'm not going to use that one. That's got a t, I'm not going to use that one. That's got a t, I'm not going to use that one. This hasn't got any t, so I'm going to use this one. Okay, so that's the one I'm going to use, and that's the one I've used there. Again, I just replace my letters for numbers, and when I work all this out, I work it out every step of the way, and then I do my rearranging there. So I've got minus 13.4x. I'm going to plus each side by 13.4x. That's going to get rid of that, and that's going to bring this to that side then. So x becomes this over that. So I divide both sides by 13.4. That's going to give me 13.4 meters. So available there is, oops, I didn't want to do that. Available there is 6 marks, okay, for the Souvat, the xvat. The next question I think we coped well with as a class. You just need to realize that when it's asking for, well, when we're dealing with moments, let me just show you the, where it is going to be force times distance there, okay? So whenever we're dealing with a pivot or anything like that, it's going to be a moment. So I've said there that this side, the moment this side, force times distance, is going to equal the force times distance that side to keep it in equilibrium, so it's not moving. So just be careful of the units. I always like to convert. Sometimes it works out. I always convert because I'm never sure on which ones sometimes, at least when I was in school. I was never really sure which ones that I needed to convert and which ones worked without the conversions. These probably work without the conversions, although I convert anyway. So 20 centimeters is the same as 0.2 meters. And it's just a really good habit to get into. And especially if you're going on to do this at a higher level or any sort of maths, just get those conversions done. So 0.2f equals 4 newtons times your 0.45 meters there, because I've converted that. And then once I start solving, it becomes 9. And again, if you're struggling with the rearranging there, I'd advise you to seek out some help. 3 marks there. A slightly tougher one, whereby the big mistake here is not taking into account that the distance from the pivot to the end is actually 1.5 meters. So a lot of mistakes here, just putting just 0.5 and then looking for the force. So pretty much you've got someone this end who's going to weighs 400 newtons. So you've got this force coming down. This child here is not able to quite keep the equilibrium, so you need this guy here just pushing down. And we want to know what the force is that he's pushing down with. So we need to take into account that distance from there. Okay, so this force plus this force is going to equal this force. And the way to do that, you can just have a look there, that I've sort of taken it step by step again. My 400 times my 1.5, because it's already in meters this time. That's going to equal, okay, 1 meter times your 300 newtons plus whatever force this guy's pushing on, but he's 1.5 meters away from the pivot. And once you work that out, you come up with a force of 200 newtons. This next one is momentum. So let me just show you back here. So we got momentum equals mass times velocity. So that's what I'm going to use in this time. And I've tried to make the first one as simple as I can. It's 4 marks. So we've got a skater, 75 kilograms, moving up 4 meters per second. So I've chosen a direction there. And that's going to hit a stationary skater who's 50 kilograms. So I've just put 0. It doesn't matter about the direction there. So everything this side now, because the conservation of momentum, okay, is going to equal everything this side. And you got a combined mass now of 75 plus 50. I've even done that for you. And we're looking for V. So this is just a case of rearranging. So M1 U1 plus M2 U2 is going to equal M total and then V total. So 75 times 4. So 75 times 4 plus 50 times 0. Well, we all know that's going to be 0. Equals 125 V. So it's 125 something. So that's going to be then just 300 plus 0 equals 125 V. So 300 over 125 equals your V there, which comes out to be 2.4 meters per second for 4 marks. Going to use the same equation now to do this slightly harder one. Let me just tilt that properly there. They're more difficult numbers and a bit wordier, no diagrams. So I've done myself some diagrams here. Pretty much comes out to this ball A, being 0.08 kilograms, moving at 9 meters per second. B is moving in the other direction at 3 meters per second, and it's 0.36 kilograms. Now they don't combine this time. It says the 2 balls collide and they move away from each other. But ball B stays stationary. So I can give that now meters per second of 0. All right, but it's still got the same mass. They've still got the same mass. So I'm looking for this. So if that's going to be 0, that's going to be 0, isn't it? So it's kind of the opposite way to rearrange here of the one we just did last time. And then once it all comes out in the wash, we get 4.5 meters per second. Okay, so you can just have a look at the way I've done that. You can see what I've done. Go to the last question then, which is the kinetic energy lost. Well, let me just show you the kinetic energy, the formula, and you'll be using this in double as well once we finally get on to kinetic energy, equals half mv squared. And it looks quite complicated, but really it's 0.5 times your mass times your velocity squared. That's all it is. So once we start using that, and what I've just found out there, so I'm going to need to know this in order to push on to see if there's how much energy is lost. So again, conservation is energy. Energy is never created or destroyed. It's only transferred. So we're looking for how much energy is lost in either the heat or the sound that was caused in the collision. So I'm going to use a KE equals half mv squared equals KE equals half mv squared this side, because they have to equal. Okay. And if they don't, we can find out how much they're going to be. So first of all, I need to find out how much energy is in this side, how much energy is in that side. And then once I've found that out, and that's really easy to do, like I said, 0.5 times 0.08, my m, and then my v squared is 9 squared. And I get all that from up here, yeah? All this is from here, from my 9 meters per second there. Plus, because I've got two balls colliding, so there's the energy this side, it's 1.62. And then I've got, this comes out to be 0.18. So 1.62 minus your 0.18 energy there is going to be 0.81 again. It just works, it's just funny how it works out the same, it's just like half. And that's how much energy is lost for 4 marks. Like I said, I'm going to give you another test on Thursday. Just having a look now. Actually, I don't see you. Yeah, we could be... So the next time I see you, you're going to have another test on this. But this will be very, very similar. I'll just probably change the numbers around and maybe slightly change the questions. But, you know, we need to start practicing these questions like this because that's how they tend to come up in the exam. Okay, thanks for listening.